Looks like we're live. Hello everyone and welcome to yet another Azuzin session. Let's make a little bit of an announcement and officially start the stream. As usual, as always, so let's do a red circle and live on Twitch. And what are we doing today on Twitch.television website? Today we are revolutionizing web with C and WASM. How about that? Isn't that a cool title? I think it's a pretty cool title, right? Because that's what we're doing today. We're revolutionizing web finally. I'm gonna give the link to https twitch.tv/todding, the place where we're doing all of that, and I'm going to ping everyone who's interested in being pinged. There we go. The stream has officially started. So on the yesterday stream, I was trying to get some pixels of an image in a web browser. You would say that that's relatively easy, right? So, but I mean, you're probably thinking about displaying the images, right? But I didn't need to display an image. I needed to get like literally pixels. I wanted to have an image as an array, a literal array of pixels through which I can iterate and maybe process and maybe do something and stuff like that. And apparently in web, it is not as easy as you would think. Yes. It is not as easy as you would think. Right, first of all, you need to somehow get an image itself, right? So you need to download it, usually with some sort of like an image tag, right? So let me actually grab my HTML page, right? So for the demonstration purposes and stuff like that. So you need to get the image tag. You have to put your image in here, right? Your image, there we go. So that will display the image. Sure, that will display that image, but that won't get you the array of pixels. So what you have to do, you'd have to take that image and place it on a canvas, right? So you have to use the canvas like draw image, and then through the canvas you would be able to get the pixels, right? So you can only get the pixels of a canvas. And in my opinion, this is dumb. This is absolutely dumb. Considering that web is supposed to be the future platform of cross-platform applications, right? You develop things for web and it works everywhere. For such an important platform, this is dumb. I think this is dumb. This is absolutely dumb, and I don't want to do that. So I was thinking about an alternative solutions to this kind of stuff. And I came up with the following thing. So effectively, in a JavaScript site, so let's actually take a look at what we've got in here. Right, so we can have a fetch, right? So do you guys know what is a fetch? It's actually kind of cool function, which allows you to fetch a certain URL, and it gives you the response, right? It gives you the response. We can take a look at what the response is capable of. It's just like an interface. It has headers, some status and stuff like that, but most importantly, it extends a body. So if we take a look at what body has, it has a lot of interesting things. For example, array buffer. Right, so, and blob and stuff like that, which allows you to get the stream of literally bytes. So effectively, if we do the following thing, if we take our image from here, right, so if we just like, did I already remove it? I already removed it, so let me bring it back. So if I literally fetch this entire thing and then I take this entire stuff, right, and in here I'll do a blob and then maybe so what blob had? I remember, maybe not blob, but yes, stream. I'm supposed to have a stream, right? So, and if I do a stream, I suppose I will get like a bytes, literally bytes of an image, right? And essentially, if you have some sort of a PNG image, right, and if you take a look at the bytes, this is literally that what you get. But this is not particularly useful for you. It's not particularly useful for you because it's not parsed. Right, so it's a like basically unparsed PNG format, and that's why you probably want to go through these loopholes of first downloading it with image, right? Downloading it with the image in here, because thus you would trigger the browser to parse the PNG for you, so you don't have to deal directly with the PNG format, right? But in 2023, we have such a cool thing as WASM. right? It's literally a virtual machine inside of your browser, and it's also a compilation target. So you can take any C code and compile that code for that specific virtual machine and run it in your browser. So what if we took a C library that can parse PNG, compile it as WASM, then we literally took the bytes of the image and feed it into that library, let that library parse the shit and give us back the array of pixels. That way, like, we directly get what we want. And we don't have to go through these stupid hoops of instantiating a DOM node, letting the browser to download and parse the image. Then we have to instantiate the off-screen canvas. Then we have to draw that image on that off-screen canvas, and only then maybe we can get the data image of that image, and it's maybe we're gonna have pixels in there. No. In software development, if you have an image and you want to take a pixels, you should be able to grab the pixels of an image directly, without any of that web bullshit. You know? The time has come to revolutionize the web with C and WASM. Alright? So, how did you like this intro? Was that a good intro? I think that was a good intro. All right, so we've got some subs. Thank you so much, Royal Flush Guy, for Twitch subscription with the message, "Hey Todding, how are you feeling?" I'm feeling a little bit down, but that's normal for me because I live in Russia. Right, so it is normal to feel depressed all the time, every time. All right. So, and the question is, what kind of library are we going to use? We're going to use some sort of a libpng or some other shit? No, we have a pretty cool library in here, which is called STB image. Right, it's a header-only library. It's literally one header library, and it supports a lot of formats already. Right, it supports a lot of formats already, and let's take a look at what we can have in here. So if we open it, of course, because it's a pretty big file, even though it's a single file, it's a pretty big one, right? Because it implements a lot of different stuff. So I want to take it raw. Let me actually download it locally. So I have some unsaved changes, but I mean, nobody cares. So let's just download this entire thing and open the file locally, stbimage.h. Right, so this thing is capable of parsing such things as JPEG, PNG, TGA, BMP, PSD. Can your browser parse PSD files? Freaking Photoshop files? I don't fucking think so. To be fair, I'm not even sure if this entire idea will work out. So the whole stream today is to actually see if this will work out. I've been you know, exaggerating my cockiness, right? So, but at the same time, I'm actually not sure if it's gonna work out. Because I've never done that before, so maybe it won't work out and we have to actually use that stupid web way of doing things, but I really wanted to try it out anyway, because I think it's a pretty interesting idea. Right, so usually what you do STBI load, right? So, and here's an interesting thing. This function actually reads the file system. So it kind of expects you to be able to work with the file system. Right, and we don't really have a file system in WASM. We don't have anything in WASM, in fact. Right, WASM is sort of like this, you know, virtual machine in a vacuum. By itself, the only thing it can do is just like manipulate the memory and crunch some numbers. That's it. It's literally incapable of doing anything else. The only thing it additionally can do is to occasionally call JavaScript code. So essentially, if you want to do something that JavaScript can do, you have to call the JavaScript code from within the WASM. That's what you have to do, right? So, and we don't really have the file system in here. Right. So, but as far as I know, you have a function from memory. That's exactly what I'm talking about. You should be able to say like a load from memory. So essentially, if we manage to get the pixels, the bytes of the PNG image and lay it out into the WASM memory, we then should be able to call this function, telling where this image is like starts within the memory, and it should return us the pointer to the bytes essentially. So which is rather interesting, right? Because we never specified anywhere like where is the destination memory, right? So that means this entire thing should be able to allocate the memory itself somehow, right? So, and as far as I know, it allocates the memory probably through a macro, stbi malloc. Yeah. So you can define stb malloc, realloc, and free. So we'll probably have to implement those, right? But it shouldn't be difficult to implement those. Right, so because you will see why, right? So because we're not going to have any sophisticated allocators or anything like that. But by default, I think all of those things, they are calling to things like malloc, realloc, and so on and so forth. Right, it uses a little bit of a C, and I'm pretty sure it also uses like a math. Yeah, it's using math library. So maybe one of the things we can try to do, we can try to basically implement some of the functions that this library needs in JavaScript, right? So math functions should be easy to implement in JavaScript because we have like literally a math module, like so, right? So here is the math. So if the C code will need any of the mathematical functions, we'll just proxy this kind of stuff to the C code. Super easy, right? Should be super easy. In terms of memory allocation, we can implement our own malloc, and we can implement it based on basically bumping the heap base, right? So essentially, we're going to be compiling this entire library with Clang, and Clang actually creates a global symbol called heap space, which points at the place in the WASM memory after which you can actually do whatever the fuck you want, right? And usually you implement the allocator by just bumping the position of the heap base, right? So you need like a 1 kilobyte, you just like add 1 kilobyte to the heap base, you get this chunk of memory, and you work with this chunk of memory. You need more, you just bump it even more, and so on and so forth, right? So that should be pretty straightforward, I think. I do think so. Right, and we can even, we don't even have to implement free, actually. We can basically deallocate everything this library allocated right after we finished working with it, right? So, because none of this stuff that it allocated really needed. So that's basically the idea that I have. That's basically the idea. So what we're gonna start with? First, I want to start with trying to get the bytes of the image, right? So just to confirm that I can actually do that, right? So I think that would be kind of important. So let's go ahead and do that. So here we kind of have like an entry point, right? So this is the entry point. And I suppose here I'm gonna just like return afterwards, right? Because I just want to experiment, right? So everything after this return doesn't matter, right? Everything after this return doesn't matter. And here I'm going to try to fetch this specific image of cute people, right? So I'm gonna actually do something like this. There we go. So this is the image that I want to actually process, right? So let me go ahead and just do that. Let me go ahead and just do that. So, all right. So there's that. And since it returns the promise, right, so we should be able to like sort of flat map it, right, and then get the stream. So I'm not really sure. So here is the blob, right, it also returns the promise. That's why I couldn't just directly get the stream. So that means to make it actually work properly, all right, I have to chain the promises, right? I have to actually chain the promises. Or maybe if this function was a sync, right, so I wouldn't have to do that. Right, one of the things I could do is probably do something like response. Right, so then await. By the way, I'm not sure if this is a correct syntax, and I don't care, right? So what I'm doing right now, I'm just laying out the logic. And after I finish laying out the logic, I will go back and see if I have to fix anything. Right, so response blob, right? So, and that will return me the promise, right? And inside of the blob, we're going to have a stream, and this is a readable stream. I'm not really sure what is a readable stream. Right, so you have some stuff in here, so you can get the reader, but can you get the actual bytes in here? So you can do pipe 2, you can do T, readable stream. So you can get the text, but I'm not really sure about the text specifically. Okay, so let's actually go back. So this is a blob, and then we're gonna have a stream blob. I'm actually surprised that, oh yeah, it wants to await. Yeah, so that's pretty cool. Surprisingly, TypeScript doesn't really complain too much about me like using this particular syntax. It's actually kind of interesting that it doesn't complain about that. Right, so what it complains about here, unreachable code, which is fine, which is totally fine in my opinion. So it's totally fine that it's unreachable. So it's not particularly convenient, right? So maybe I should actually do something like function async try getting bytes of image, right? Try getting bytes of image. This is where I want to move this entire stuff, right? So, and then I'm gonna do console stream, just I want to see what's going on in here. So in this one, I'm probably gonna move this entire stuff to like literally a separate function. So, and what this function is going to be, that's a good question. I suppose this is basically the Autocell entry point, right? So this is Autocell entry point. Right, so let me see, yeah, something like this. So, and the reason why I want to be able to do it like that is because I want to be able to switch between different entry points and whatnot. Right? I think it's kind of a useful way of doing that. So at some point I can do Autocell entry point, right? So this is Autocell entry point, or sometime it's just like try getting bytes of an image, right? So that's basically the idea. If I try to now compile this entire thing, so this is going to be in TSC. So what is going to happen? Okay, so it seems to be compiling. So let me actually start the web server, HTTPS server 6969, right? And we'll see what's going on in here. So we've got some subs, by the way. We've got some subs. Thank you so much, Carlos Henry, for Twitch Prime subscription. And Velkolepny Meister, thank you so much for tier 1 with the message R. With the message R. Okay, so let me see what's going on in here. Right, so let me see. Let me take a look at the console, right? So we're gonna see something. So I'm trying to load some shit that doesn't exist in there, which is expectable, which is totally fine. So let me remove that stuff. And yeah, there we go. So we have a readable stream, and it's locked, right? So I'm not really sure how exactly you use readable streams. So this is something that I'll have to learn on today's stream, right? So it's parameterized by this thing. Maybe the thing I have to do, I have to actually go for array buffer, right? So, and inside of an array buffer, so you can actually slice this entire thing. So I suppose one of the things you have to do, you have to construct the uint8 array out of the array buffer. So that's one of the things you probably have to do. So let's actually give it a try. So instead of the stream, we're going to do blob array buffer, right? So, and this is basically a buffer. Right, and I just want to see what's the buffer, right? So do I have an auto revert? I don't think I have an auto revert, so I have to set it up basically. So I would have to set it up. So let me go to here, super quick, boom, boom, and I'm gonna do TSC, actually bin TSC watch, right? So it will do auto revert automatically. So is it done? Is it not done? Okay, there we go. So now we have a promise, right? So now we have a promise. So that means here I should have awaited this entire thing. So we have a buffer, and the size of the buffer is actually 100. Yeah, 104 to 3. So basically one 0.5 kilobytes. And if we take a look at the size of this entire thing, it is actually this thing. So we actually got the bytes. So I suppose to get this thing as like an actual, bytes, what I have to do is maybe wrap it in uint8 array. Right, so maybe that's how you do that. I'm not 100% sure, but the TypeScript doesn't complain. Right, so that means you probably can do that. Yeah, you can do that. Okay, that's actually pretty cool. And if we take a look, I wonder if I can view this kind of stuff. So if I basically take first like 4 bytes, right? If I take first 4 bytes and then go to somewhere like Python 3, all right, and just do something like that. So I have a list in here. Can I map this entire thing with CHR? All right, is that something I can do? So then turn it into a list, and as you can see, it is in fact a PNG. We successfully got the bytes of PNG file. It is in fact possible, right? It is in fact possible. So yeah, so the only thing that is left in here is actually, compile the library to WASM, right? Compile the library to WASM, and then instantiate that WASM module in here in the browser, then take the bytes of this image, like put it into memory, and just let the library parse this entire stuff. And the library should return something to us, right? It should return the actual bytes in here with which we can work, right? So that's actually kind of interesting. And furthermore, this approach is actually more, how to say that, more flexible than relying on the browser. Because maybe you would work with images that are not supported by the browser, simply. They're simply not supported by the browser. You can always just like add support on the level of WebAssembly, right? You can just let the WebAssembly to parse all of that. Sounds pretty cool. All right. That's pretty poggers. So we've got a sub. Thank you so much, Logits, for Twitch Prime subscription. Thank you, and welcome to our epic C club. That's right, C for web. Who needs JavaScript? C is the future of the web. All right, so let's continue. So the question is, how do we even compile STB image as a module? So that's a very interesting question, right? So essentially, right, so the problem with this thing is that it's a header, right? So, but it's a header that acts both as the header and the C file. But to make it act as a C file, you have to actually enable a special macro, right? You have to define a special macro called STB image implementation, right? So let's actually try to create STB image.c, right? And we're going to include STB image.h into this file, and we're also going to define STB image implementation. So that way, STB image actually acts like a C file for its STB image, right? So STB image now acts like a header file, and this is a C file because it includes H, but with this specific macro, right? So now we can try to compile this entire thing with Clang, right? So with Clang, we can do STB image.c, right? And it will try to compile it as a program, right? It will try to compile it as a program. It will take some time, right? Because Clang is slow, right? So essentially, it complains that it cannot find the entry point, right? Because by default, it tries to compile it as the program, as the executable program, right? To compile it as sort of like object file that you're supposed to link with something else, like with C library and stuff like that, you have to provide -c, right? So, and it should create an object file, right? So it created an object file, and as you can see, it's a ELF 64-bit LSB relocatable x86 64 version 1c5 not stripped, whatever the fuck all of that means, but that's what it is, and it isn't what it isn't, right? So interestingly enough, this is not what we want. It's a ELF 64-bit, but what we need is WASM 32-bit. That's what we need, WASM 32. So as far as I know, in Clang, you can provide the target, right? So it's a target flag, if I'm not mistaken. So it has to be WASM32. Will that work? Okay, that one is interesting. It kind of worked, but it already complains about different stuff, Right, file not found, stdio. This one is interesting. So the creator of this library is actually very experienced low-level game engine developer. Not only just experienced, but he's also old school, hardcore, low-level C game engine developer. Right. He's the creator of the engine for the game Thief. Right. Thief game. Is that how we spell it? I don't know. So yes, you're supposed to put I in here. So English is not my first language, so I don't really speak English at all. So I had to actually learn it myself. So I'm sorry that I cannot, you know, spell some of the things. It's 2014, but I wanted to see the original one. Right. So one of the creators of like the engine of the original thing. Right. So that's how cool he is. That's how fucking cool he is, right? So, and because of that, he saw that you might want to actually compile this library without any standard IO. He actually saw that with his years and years of experience. He actually saw that, right? So that means we can disable IO support in this library by just like enabling this thing. And that actually simplifies implementation, because we won't even have to implement any IO for this library. Sean is the true GigaChat. Yeah, true. I could not agree with that more. Right. So he occasionally also streams on Twitch, as far as I know. His Twitch is Nothings 2, right? Because I suppose Nothings was already taken. Nothings 2, Electric Boogaloo. Right, so he doesn't really stream that often, but he streams sometimes, and his streams are extremely fucking cool. So, yeah, so I could not recommend him more. So check out his stuff. All right, so Twitch is very slow for me, I'm sorry. So one of the things we probably want to do, we want to disable the stdio, right? So let's go ahead and do that. It's actually kind of surprising that it automatically actually set that it doesn't have any of this stuff, but anyway. Okay, stbi, no stdio. stdlib. Okay, so does it have stdlib? It doesn't really have that, right? So stbi def, we can't really easily disable stdlib, unfortunately. We can't really easily. So this is stbi include. It does need stdlib, but I'm not really sure what it needs stdlib for, right? So what it needs it for? Can I replace stdlib with stddef? Maybe that's what we can do in here. Right, file not found. Okay, so maybe we can do something like this in here. So string is not found. Okay, so can we disable that stuff as well? Math is not found. All right. No linear, no HDR. All right, maybe we can actually disable the math by doing something like this. So I'm going to define stb no linear, right? So is it going to work? So not defined. If, well, I mean, oh, if it's not defined. So that means we have to undefine, but where is it defined though? So let me see. If not defined, all right. I don't think it was ever defined anywhere, right? So it was never defined, so it's not defined anywhere. So, but it still complains about this kind of thing. Right, it still complains about this kind of thing. I'm surprised that it doesn't simply, you know, support this entire stuff, right? So just because I was trying to compile with target WASM32, it's just like it literally cannot see any of this stuff, right? It literally cannot see any of this stuff. So yes. So let me actually see. So maybe I need to... Just a second. I'm going to try this kind of thing. So file not found. Maybe I just need to just like enable both of these things, right? So let's try to enable both of these things. Let's try to enable both of these things. So assert doesn't really have assert, but we can define our own assert. Specifically, we can say that we're not going to have any asserts in here, right? So essentially, we're going to just like ignore this entire thing. And I think, yeah, that's actually cool. I think it worked. I'm quite surprised that I had to go through all of that stuff, right? Especially with stdlib, I had to replace stdlib and stuff like that. But overall, I think it kind of worked. And if we take a look at what we got in here, right? What's the file? We got WebAssembly binary module version 01, right? So this is what we got. So one of the things we can try to do, we can try to basically disassemble that and see what's inside of this entire stuff. We can do WASM to what, right? So basically WASM is a binary representation of WASM, right? And what is the texture representation of WASM? So that way we'll be able to see what exactly the compiler generated for us, right? So what exactly it generated for us. Let's take a look. So there's a lot of stuff in here. And this is the assembly, right? Did it finish generating? It actually doesn't finish generating. So let's actually redirect this to stb image what, right? So yeah, so because the output performance of Emacs is rather poor, and it's actually 2 megabyte text file, right? If you take a look at the size of this entire thing, it's like literally 2 megabytes. Right, so which is kind of meh, but I mean it's a text representation, right? So the actual binary representation is like 200 kilobytes, right? So it's actually rather small. So the things I'm interested in, specifically interested in, is stbi load from memory, and I do have an access to a function, probably. I don't know if it's exported or not, right? So where is the import? Right, so this is the import, and do we have an export? I don't remember how you export things, but maybe we'll have to export some of these things. Yeah, I think we have to pass to the compiler basically a list of names that we want to export. But in any case, we do have an access to this specific function, right? So, and what's interesting is that we're also importing a lot of stuff, and we're importing the mathematical things as well. No, well, I mean, ABS is not particularly mathematical, but anyway. So here we have a free memset, realloc, memcopy, malloc, and we can actually implement all of that quite easily. So it also wants to import stack pointer and whatnot, right? It wants to import the stack pointer. So, which is not particularly great, I think, which is not particularly great. Right, because it feels like some of the steps in here are kind of missing, right? So this means that I have to provide the pointer for a linear memory. I don't want to freaking do that. Like, why do I have to do that? No, I don't want to do that. And also stack pointer and stuff like that. And I suppose most of these things are supposed to be resolved at the link time, right? Most of them are supposed to be resolved at the link time. So I have a feeling that I have to basically build this entire thing slightly differently, right? So, because I remember every time I was doing like a WASM thing, right, WASM stuff, I was providing a lot of flags. In fact, I think I know the place where I can steal some code, the Olivets. Right, because remember this particular thing, all of that stuff is written in C, right? All of that stuff is written in C. You can actually play with it if you're interested in this kind of stuff. Right, and for people who are watching on YouTube, I'm gonna actually put it in here, right? So all of that is actually compiled to C, so I'm gonna go ahead and steal some code from there. All right, so let me see. I probably have a local version of this entire stuff, right? I do have a local version of this. So Olivets, is pretty sure to be pizdet. All right, so what do we have? So WASM demo, there we go. Yeah, now we're talking. So there is, yeah, we have to provide the target, WASM32, no standard library, no entry. Yeah, I completely forgot about that. There is like a whole process of this entire thing. Yeah, so let's go ahead and just like port this entire stuff. So maybe I need to have some sort of a build script, right? So maybe I need to have some sort of a build script. But you know what's interesting is that I'm developing a JavaScript project. So that means I can use JavaScript as the scripting, as the building language, right? So essentially can call Clang from JavaScript, right? So let me actually see. So Node.js run external command. So how do you do that? That's very interesting. How to execute a shell command in JavaScript. So there is a require child process. Okay, that's actually kind of cool. So let me go to here and let's create something like build. And since I'm using TypeScript, I think I can just use a TS. And I wonder if I can do require, right? So is require something I can do? I don't think so. So child process. So I think you can do some shit like that, can't you? Right. So I hope child process is not a third-party package. You can use child process. So require child process exec. All right. So that's pretty cool. Oh, you can like literally just like execute a shell or something. Okay, that's cool. Can I still do that? Is that still a thing that works in here? Right, and then I can do some, so you can even have an access to like a standard output and standard input and stuff like that. And I want to just do something like hello world. Actually, I want you to do echo, but maybe not. So let's actually do cut build ts, right? So we keep building, so we cannot find require. All right, so I suppose I have to do something like import. Maybe, yeah, I don't quite remember. Type script import module. Let me see. Import module, documentation modules. So let's find out. Oh yeah, okay. So exec from child process, or you're supposed to probably put these kind of things in here, so that way we don't have to do that stuff. Semicolon, is that what you want? Cannot find a child process. Okay, so maybe I have to, oh, I probably have to install typings for TypeScript, right? TypeScript child process typings, right? So that's probably one of the things I have to do. Oh, it doesn't, it may not work exactly as I think it would, right? So that's the problem. You know what? I really don't want to deal with that. Yikes, I really don't want to deal with that. So this is like literally the last thing I want to deal with right now. So fuck that. So this is going to be JavaScript, right? Wait, it generated something. It generated some bullshit. Okay, so let me actually get rid of this entire stuff. Right, so I'm gonna just remove that. Fuck all of that. And we're going to literally just do require. Right, so const child process. Child process exec, and hopefully, maybe it will do the trick. I have no idea, because it's JavaScript, you never freaking know. Alright, node build.js, is it going to work? It did something. At least it didn't complain, which is already freaking cool. Right, so the next thing we're supposed to do, I think, right, so let me find this thing. So you have a function which accepts error, stdout, stderr, right, so error, stdout, stderr, and here we can just basically print all of that, right? So let's see, console log, I'm gonna literally print stdout and see what's going to happen. Yeah, there we go. So it basically, we implemented Quine. We literally implemented Quine. How about that? Without any TypeScript bullshit. All right, so that's pretty cool. So what I want to do in here is essentially just call the entire thing. So what I don't like about it is that it probably waits on this entire stuff, right? So if we take a look at the documentation, the command runs with the specified arguments, right? So let's take a look at the callback. Callback. When the process terminates, right? So it doesn't really return the output as it goes, right? So maybe there's a lot of output for the command. So spawn, maybe this is what we have to do. So spawn history doesn't explain anything about this entire stuff, right? Doesn't explain anything. Does it have a callback? All right. So you can do fork. Method spawns a new process using given command with the command line argument if immediate. If the shell option, yeah, I don't care. Like, how do you use it? Oh, this one, okay, so this one is actually, yes, this is what I'm talking about. Right, this is a good command. I really like this command, right? Because you can basically say, okay, on stdout, every time you receive some data and stuff like that, you just like process it, right? So I suppose it basically can return this kind of stuff in chunks. Right, so this one is good, right? So we can use that. Spawn, child process, spawn, right? Cool. Spawn. So here we want to do clang, and I really like that it accepts this kind of stuff as array. So that means we can actually maybe append some of these things, right? So arguments and options and so on and so forth. That's pretty cool. Right. So how are we gonna do all of that? So where is my no build in here? First of all, we're gonna do some, I can even copy paste this kind of stuff, right? So we're gonna have some optimizations, maybe. Probably not, but maybe. Let's actually put some optimizations. We're gonna disable all of the built-in optimizations, right? So it doesn't screw up with anything. We're gonna set the target to WASM32. So we're not gonna use any standard libraries, even though maybe it would make sense to use some of the standard libraries, but one of the things I want to do is that if it uses something standard, just try to import it and I can implement all of that stuff on the JavaScript side, right? So this is something that probably want to do actually instead. Right, so the next thing is we're gonna say no entry point, right? Don't provide any entry point. And here we're starting to export some stuff, right? So what do we want to export specifically? Right, so as already said, we probably want to have load from memory, right? So that's the most important thing that we want to have in here. Right, so load from memory. So we also want to export heap base. This one is going to be important for implementing the memory allocation. Allow undefined, and this is what I was talking about, right? So essentially, if it won't find any stuff from the standard library, just like, you know, just import it, and we'll be able to implement that on the JavaScript side. So then we have to provide the output in here. So we're going to output stb image WASM, right? So that's going to be the output, and that's basically it. So the rest of the stuff we have to provide stb image.c, right? And because of the allow undefined, I suppose maybe it should be relatively easy to allow math, right? It should be able to we should be able to actually allow math. Right, so also in here we have a bunch of common flags. I don't really remember what they are. Sanitize memory. I'm not sure if that's going to be useful for us, but I mean, it's not common flags. I'm an idiot. I'm sorry. Yeah, so basically all of the possible warnings, pedantics, the standard. I don't think we're going to enable all of that, right? Okay, so we're going to spawn this entire thing. Right, and this is going to be clang, right? We spawned the clang on std out, clang on. So what is that? Std out on data. We're gonna simply do. Can I just do console log? Right, I should be able to just do console log. And then std error, also console log. And on close, I don't really know. Do we want to do anything on close? The only thing I want you to do, I just want you to call the external command. Right. So I just want you to call the external command. So let's actually try to. Not bad. Okay, so this is the buffer. Thank you, Node.js. Very cool. Okay, so now I have to Google Node.js buffer to string. Okay. How to convert buffer to a string? Yeah. See, what the fuck am I looking at? Okay, is there a better command though? Is there any better command? So fork, maybe fork is a better one. Module path, no, probably not. Synchronous process creation, yeah. What if I, like, the problem here is that if I don't provide any of this stuff, right, is it going to print anything? Right, it's probably not going to print anything, so that's the problem. And it's hanging. I'm not even sure why exactly it is hanging. Something is dangerous going on. I don't really know what the fuck is going on. Okay, so let me see. Right, let me see how we can get rid of all of that. So what the hell is going on here? Yeah, probably. So let me put it like that. Query replace this with space. Boom. Oh yeah, so there is a lot of output in here. There's a lot of output. And okay, prototype less function used with conflict signatures, which is fine. All right, and it generated something. Okay, so it generated some stuff in here that we can finally look into. Right, it's going to be WASM to what? Right, so let's take a look at WASM to what. I probably want to do something like WASM to what, STB image, WASM to STB what. Right, so let me see, what do we have? So what are we importing here? Yeah, this is precisely what I was talking about. Finally. Right, so it doesn't have this weird stuff like stack or linear memory or whatever the fuck it was. It only requires these functions that we can kind of easily implement. Right, so does it have an export? Yeah, it exports memory. This is important. It exports STBI load from memory and also heap base. We have freaking everything to actually pull that off. Holy fuck. All right, so this is actually pretty cool. We maroon somewhere. So because I think I needed to do all of this stupid hacking with this stuff. Where is the C? With this kind of stuff, because I was compiling this thing incorrectly. I want to try to maybe get rid of that and see what's gonna happen. Right, so I just want to see. It still wants math. Right, so this is actually really strange about this kind of thing. Right, that math just contains the headers, you know. It just contains the headers. Like, why do you need all of that? Right? Why do you? I mean, the signatures. Right. So why can't you just include it? This is something that I don't understand. You can just include it. One of the things we can try to do. Let's actually see what are the functions it's complaining about. Though it's complaining about not having maybe I don't know. I don't see it. Where are any mathematical functions? Is there any mathematical functions? I can't really see anything, but it seems to be fine. Anyway, so I'm gonna try to convert it to what, and within the what, we're gonna see if we're exporting. Yeah, I suppose that's what we need. LDExp. And this is a mathematical function, right? Yeah, so it needs math for specifically that. And what is LDExp though? What is LDExp? Result multiply x to raised. So yeah, I guess that's fine. I guess that's totally fine. So let's go to here, right? So and you know, disable this kind of stuff back. I really want to be able to just use JavaScript to run this external thing, but I mean, it's really dumb, right? So apparently, like, I just want to spawn the external command and redirect the std out to my std out. How hard could it fucking be? Apparently, it is very, very hard. Right. So let me see. Let me see. Like, this is stupid, right? So data is a buffer. It's not going to tell you anything. All right. So yeah. This is very, very dumb. Node.js, let me see. Node.js run external. Let's actually try Google, because maybe it's DuckDuckGo that being dumb. I'm from within Node.js with std out. Maybe I'm gonna actually specify. Run shell command and std out as it arrives. Yeah. So people are talking about it. So I have a question to all of these people who suggested this thing. Have they tried to do that? Or maybe I am the one who's dumb, right? Because maybe if you use like a string interpolation, it is going to convert it automatically to string. So it's just like so weird to me. Like, why are you suggesting it like that? It's just so dumb. Right. So yeah, let me try to do that one more time. It's just like, people, it's freaking Stack Overflow, I swear to God. Cling. There we go. So it's taking some time. Is it working? Is it doing anything? I'm not sure if it's doing anything. Are you doing anything? I don't freaking know. You know what? I guess fuck it. Right? I could not be bothered to deal with all that. I'm sorry. Right? I'm not a web developer. Web developers apparently have an enormous patience when it comes to like web bullshit. I have no idea where they get all of this patience, because as soon as I see this kind of bullshit, like, no. Just fucking, why do I have to deal with that? Right. So I just like don't understand. How are you people so fucking patient? Like, I couldn't give a less shit. Right? I just couldn't give a less shit. There's more quicker and easier solutions. And it's just like, yeah, fuck that. Anyway, so, okay. Right. All right. So there's a little bit of a shit in here, right? So, but I think I'm going to ignore that. And what we are going to do, the first thing we have to do, we have to instantiate the WASM module, right? Instantiate the WASM module. But I think I'm gonna do that after a small break, right? So I'm gonna make a small break, I'm gonna make a cup of tea, and after the break we're gonna continue. All right, so let's actually try to instantiate the WASM module that we've got. Right, so we managed to compile something, right? So we managed to compile something. Now let's try to instantiate this entire thing. So I'm gonna go to here, and I don't quite remember how you instantiate the WASM, right? But I already done that in Olivettes, right? So that means I should be able to just do that, right? So just copy paste this stuff. Let me see. So there was some code in here. All right. So here we're getting the you know, the node stuff, initializing and everything. Yeah. So the cool thing is that WebAssembly module has like instantiate streaming, right, which can accept the promise that you receive from fetch, right? So, and it makes it actually very, very convenient. So let's go to where, right, try getting an image. So here we're getting the image itself, right, but we're going to be also instantiating some stuff. Web assembly. Surprisingly, TypeScript has stuff for this kind of thing, so that's actually kind of cool. Right, so what's going to be the rest of this stuff? Instantiate streaming. And we're gonna try to fetch the WASM module that we have in here, right? So I'm gonna literally just fetch stb image WASM, right? stb image WASM. So here I also have to provide the environment, but I'm not kind of sure if I need to do that. So if something is missing in an environment, I think it will complain, and I want it to complain because I want to see what it will say, right? Because that will guide us through the process of troubleshooting and stuff like that. All right. So did it recompile everything? So let me restart the watch mode just in case. Right, so it seems to be all right. So it complains that I don't use this entire thing, but it doesn't really matter. So let me actually refresh this entire thing. And it's complaining that we don't have an environment in here, so that's fine. So essentially, we probably need to put env in here specifically, right? So we need to put env in here. So, okay, so it doesn't have a free. Right, so essentially, it will start complaining about missing of all of the functions that it imports in here, right? All of the function that it imports in here. So I actually want to go back to the moment where we disabled this, all of this stuff. I think I already enabled it, but I don't remember if I recompiled this thing. So I'm going to try to recompile it one more time. Right. And I'm going to create WAT file just to see, just to confirm that it doesn't use any mathematical stuff. Right. So, all right. So let me do this thing, and I'm going to go to WAT. All right. I'm going to go to WAT. And yeah, it doesn't use any mathematical stuff, which is kind of cool. All right, so let me refresh. So here's an interesting thing, right? So we can try to define free, and we can try to define all of these things here manually. We can try to do that, but it's kind of tedious. And in Olivettes, I actually came up with a better solution, basically proxy environment. So essentially, it defines all of the possible functions, but it defines them with a stub that just prints not implemented at runtime. So it makes it sort of dynamic, right? So, which is actually kind of cool. So essentially what you can do, right, so we're gonna copy paste this function in here, like so. So it complains about, I'm not sure why it complains about that. So what you don't like implicitly as any, okay, so whatever, I'm gonna just like leave it as it is. And essentially what I'm gonna do, I'm gonna say make environment, right? In this particular environment, if the WASM instantiator will try to get any of the functions, it will get them. So we basically automatically define all of the possible functions, but with implementation that just throws an error in like not implemented. So which makes it rather convenient, in my opinion, right? Which makes it rather convenient. Okay, so let's actually refresh this entire stuff, and as you can see, it successfully instantiated everything, right? It's successfully instantiated. You won't be able to really call anything in that WebAssembly thing, but it's instantiated it nonetheless, right? So it complains about the function stuff, right? So I would like to maybe fix it somehow. Let's say that we're gonna have an environment, right? So this is an environment, and as far as I can remember, an environment, right, is, we can define it as an interface. Right, we can define it as an interface which has a key as a string, but value is a function, and in fact it's function like it's any function. It's kind of hard to tell. Right, maybe we can define it, let's actually say any, right, yeah. Alright, so what do we have in here? Rest parameter must be an array, so I suppose I have to say something like this. Oh, okay. So that's very interesting. So what you complain about here is declared but value is never read. Okay, but how can I prevent that? What if I don't care about these things? Do I have to put underscore in here? Oh yeah, okay. That makes sense, sure. Okay, so has own property, and we're trying to do property symbol which cannot be used as an index type. Right, so has own property. Alright, and so the property, it's either string or symbol. Ooh, this one is interesting actually. It is either string or symbol. What if I... Probably not a particularly great idea. Right? So we can say that it accepts either string or symbol. What the fuck, an LSP? This is something that comes with the Tide. I'm using Tide. Emacs Tide. So... yeah. I'm using this thing. I installed it like a long time ago, and it just works. It's one of the rare extensions that I just installed, and it just fucking works. I never configured it, I never did anything to it, I have no idea how it works, but somehow it fucking works. And I greatly respect the creators of this extension, because this, especially in the area of web, seems to be completely impossible, right? So it just somehow works. It somehow finds the TypeScript interpreter, and it runs the server, and it just connects everything. I never had to write a single like line or configure anything. It just like automatically work. I've never seen anything like that in Emacs, in web, in 2023. It's just like, what the fuck is this shit? But somehow it just works. So, and I could not recommend this kind of thing more. And it's been like that for many years already, and I don't remember this thing ever breaking. Like it never broke. Which is fucking unheard of, right? It's just like, what kind of magic do they use that this kind of web stuff like never breaks and just always works? I don't know. I have no idea. Somehow they do that. Okay, so here we return a function of some sort of like arguments. It accepts some arguments, I suppose. It's just like we can say it's any, right? And the prop, it doesn't really like the fact that it's a symbol, right? So it really doesn't like the fact that it's a symbol. What do we know about symbols? Right, JavaScript symbol. Can I easily convert the thing to a string? Right. Right. Okay. So if I say that this thing. Yeah, I mean, it's not that bad of an idea to actually allow symbols as well. I didn't see anything wrong with that, so let's actually keep it as a symbol. But here, we probably have to do to a string, and it seems to be working, actually. It seems to be working. So, what we return in here is rather interesting. So, we return in the proxy. Can I just say that, yeah, this is a proxy. Will that work? Right, so proxy refers to a value but is being used as a type in here. Did you mean type of proxy? Probably. Okay, so, and it doesn't like that I return this thing. Proxy constructor, so I suppose I have to say proxy constructor instead of this thing, proxy constructor. Right, it still doesn't like that. Okay, so why don't you like that? Because revocable is missing in a type environment, but required in a type proxy construct. Revocable, is that because this thing, okay, so let me see. Proxy handler, right, so it has a get, and also it wants a revocable. I didn't see revoke proxy construct, so it wants me to define revocable, but I didn't think it's that important in here. Okay, that's really weird. Can I just return any? It's just yeah, let's just return any. Couldn't care less. Okay, so the type system of JavaScript is so wacky, right? So you have to put a lot of engineering into the TypeScript type system itself just to accommodate all of the wackiness. Right, so yeah, just to accommodate all of this wackiness. But yeah, so essentially we can try to maybe call the STBI stuff. Let me try to just do console log W, right? Console log W. And let's see. Let's take a look at this stuff, right? So this is an instance. So here we have exports. Here we have that stuff, and STBI load memory. So this is probably something that we want to call in here, right? So instance exports STBI load from memory, right? So, and we supposed to provide some arguments in here, so let me see what's going to happen. I need to find the thing in here, right? So STBI load from memory. Alright, so here are the arguments. So what do we have in here? Might as well actually do it like that. Right, actually do it like that. So here we're going to provide the null, right? So, well, I mean, I can probably provide 0, whatever. I'm going to provide 0 in all of them, right? I just want to see what is going to happen if we provide any in here. And it complains about these things, right? So expression not callable. Okay, so that's fine. Let me try to refresh this entire stuff. And as you can see, it complains about memset being not implemented. Memset is not implemented at all. Right, but what's interesting is that it accepts the pointer, it accepts what it needs to initialize this thing with, and how much it needs to initialize. So essentially, we're gonna go through the process of going through all like implementing one function, running it again, implementing another one until it's fully implemented, and we're gonna have the thing that probably works. We'll see, we'll see. So that's basically basically the idea. Basically the idea to implement all of that stuff. Right, so we can do the following thing. Now we can say memset, right? So this is our custom memset. And here, if I take a look at memset, right, so here is the memset, as scn, right, so this is going to be scn, and here I'm going to say, okay, custom memset, right. So essentially we're calling into here, and as you can see, it printed custom memset. Now the next thing it tries to do, it tries to like call to a malloc, so it wants to allocate a little bit of memory, right? So, and this is very important because we'll have to implement our own malloc, but as already said, implementing our own malloc is going to be really straightforward, right? Because we should have an access to heap base, right? So if we just go ahead and console log w in here, right? So we have to refresh it, right? It didn't really finish. There you go. There you go. So if we take a look at the exports, what kind of exports we have? We have a heap base, and it's a value, and this is a pointer within the memory. So this particular pointer is actually extremely important, right? So, and it is very important for us to know that specific number because it's an address in memory starting from which you can do whatever the fuck you want with that memory. Like starting from 69 by the way, right? Starting from 328 bytes in the memory, in WASM memory, you can literally do whatever the fuck you want with that memory. It's just like you can read, write, replace, like put everything in there. The entire memory is yours. literally yours. Don't touch anything before that specific address. Don't touch anything because it's reserved by the C runtime, right? It's reserved by C runtime generated by Clang, but after this address, starting from this address and further, you can do whatever that you want. So, and essentially every time the module calls malloc, we're gonna basically, reserve a chunk after that specific address and give it back. Right, and the way we're going to do that, we're going to basically have a pointer that points first at heap base. Every time we call malloc, we're going to bump it up by the size we want to allocate, and we're going to give it back. Right, we're never going to implement free, right? We're never going to implement free because we're going to free all of the memory at once after we're done parsing the image, right? So we're going to just let the entire library, leak the memory, just allocate however it wants. And then after we got the image, after we got the parsed pixels, we're going to just like swipe it out easily. So that's basically the plan. Right, so this is how it all works. Does it make sense? Does it make sense? Hopefully that makes sense, right? Hopefully that, in fact, makes sense. So let's continue. So we need to implement memset. But to implement memset, we need to get the memory as well. So we can have the memory in the exports. So let's actually quickly do that. So we can do... so this is one of the problems that we may have in here. Can I just like do W instance exports memory, right? So this is going to be memory and this is the buffer, right? So and we can say that this is the buffer that we've got in here, right? So memory buffer. So. And after that, we can essentially create a view, U8 array, and we can provide the buffer. But as far as I know, you can also provide something like S and N, right? And that way you provide like a range from within, yeah. That's how it works. Do we have constructor? I don't think it works that way, but anyway. And then I suppose one of the things we can do, we can just fill this entire stuff with C. Right, and after that we have to return the pointer, the S back, because that's how it works, if I remember correctly. That's how it works, if I remember correctly. Okay, so malloc, right, let's implement malloc. So how we do the malloc? So it just accepts the size, right? And so this is where it all becomes very interesting, essentially. So how can I do that? Maybe I can do something like allocator. Right, so maybe let's call it bump allocator, right? And it's instance exports. Where is the heap base? I just want to see. It's probably like straight in the exports. Yeah, heap base. So we take the heap base. All right, and to get the actual value, we also have to go into the value. Yeah, there we go. So that's the value. So I suppose, will the hoisting work in this specific case? Will I be able to actually access bump in here? That's a very interesting question. But in any case, we can say the result is actually the bump, right? So the result is actually the bump. And then we take the bump and update it by the size, and we just return the bump. And we can say that there you go, we just implemented malloc. It's a very dumb malloc. Right, so it's a very dumb malloc, but that's done intentionally. All right, the next thing. Free. Okay, so free is super easy. We're simply not gonna have free, right? So just like do nothing, ignore this entire stuff. Maybe we can, well, yeah, you can accept the pointer, but we can do something like this, right? Can we? Let's actually accept it like so. Okay. What else do we have to? And it worked. This is actually kind of cool. We can maybe lock every time we do all of that stuff, right? So we can try to log bump, right? Console log bump before stbi load from image, right? So maybe we can even do something like this. Maybe we can do something like this. This is going to be bump, right? And then after. So, and we can see if it actually changed. It did in fact change. It actually allocated a lot if you think about it. I'm surprised it didn't throw any kind of errors. Right. It didn't throw any kind of errors, right? That's very interesting. So, wait a second. We can actually print. How much we allocated. So stb image allocated this amount of bytes. So we can literally take a bump, right? Take a bump and subtract the heap base in here. Maybe it would make sense to just do something like this, heap base, right? So it's a little bit shorter than it's supposed to be. Heap base. Yeah, so it basically allocated 18 kilobytes of memory, right? So that's how much it allocated, right? So this is how much it allocated. It's pretty cool, right? And if we're done working with this entire stuff, we can just basically reset the bump back to heap base, and we instantly deallocated everything that was allocated by this library, by this specific call. Deallocated, because we are the implementers of the allocator, right? So when you go into implementing your own allocator, you have to switch the way you think about memory at all, right? You have to really change it, because people think that heap is this magical box. You tell it, give me 5 bytes, and it just magically does some very sophisticated computer science magic, and it grants you 5 bytes. It's just like, I don't know where these 5 bytes came from, but I must return it. After I finish to execute it, I need to give these 5 bytes back to this magical box by colon free. This is not how it works in reality. This is sort of like an abstraction put into place. This is not how reality works. In reality, what you essentially have, you have all of the memory, right? So you literally have all of the memory. You just like, you can put like anything at any point anywhere. It's a little bit more complicated in the real hardware. Yeah, there's page mapping and stuff like that, but ultimately you just have all of the memory. That's it. And the question is how you use it. And allocator is basically a way to distribute the memory, right? Like between different parts of the program and stuff like that. So in here, we have all of the memory like at our disposal, right? So, and every time we allocate the memory, we just append that memory to the place where we're using, and that allows us to very quickly deallocate everything by just like marking the pointer, which denotes the end of the memory, to the beginning. But the memory is still kind of there, but I mean, yeah, so you have to switch the way you think about the memory. It's not a magical box anymore. You just like have all of the memory at your disposal. Which makes it actually kind of easier. Actually makes it kind of easier. Anyway, so I'm surprised that it didn't crash or anything like that, because we were passing zeros in here, right? But this is because 0 is a valid address in WASM, right? What we want to do, right, what we want to do, I want to actually go ahead and put this kind of stuff into the memory somehow. This one is going to be actually rather interesting, because we would have to allocate the memory already on the JavaScript side. So we'll have to perform this kind of thing on our side, but maybe we can do that directly actually. Okay, so let's actually start with maybe a cute pointer, right? So let's call it cute buffer, right? So this is a cute buffer, and we're gonna set it to bump, right? So we're gonna set it to bump. Then I probably want to actually create the view on the memory, right? So the view on the memory. So instance experts memory buffer, and we're gonna start with a cute buffer, and the size is going to be actually not sure about this kind of thing, because I want to see all of the constructors of this thing. Can I see all of the constructors of these things? I don't think so. Let me actually Google it up. Let me quickly Google it up. Right, because it's a index, the beginning of the index, and then the size, right? It's not the second index. It's not the boundaries. It's actually the beginning and the size. I need to confirm that, right? Because it's important. Because otherwise I'm making a logical error. Byte of set and length. Yeah, this is perfect actually. This is actually perfect. Okay, so this is the buff, and then we need to do what? Right, so we need to take the size of this entire thing. Can I? So we have a byte length. Maybe that's precisely what I want to have. Right, so that creates this specific view. Right. So, but this is the source from which we actually have to copy things. The destination. Well, it is a destination actually. So this is a destination, but the source is rather interesting. The source is this. So how can we copy shit? Right? Is there any copy? Okay. int8 array copy. It redirected me back in here. Okay, so copy with, is that what I want? Copy within. It's so freaking slow, I swear to God. Okay. Target. So maybe I want to do fill. Do I want to fill? It fills only one thing in here, right? So let me see. What do we have? Copy within. Another copy. So what about fill? Value start. Okay. So copy into another int8 array Google. It's a way to copy an array. Well, not really array buffer. Okay. Yeah, set. Jeez, of course it is set. Well, I mean, obviously it is called set. Not copy when you want to copy thing. It's called set. Obviously, yeah. Sets value of an array. Yeah, I see. See what the fuck is going on. All right. So I wonder what we can, how we can do all of that. So since this is just that, right? So this is that. We have to set the buffer, and since it's an array-like, array buffer is not assignable to array-like. Did you guys know that the type array buffer is not array-like? Did you guys know that? Doesn't look like an array to me. I don't fucking know. Anyway. So I mean, if I just do something like this, seems to be work. Okay. Anyway, so now, right. So I actually copied this entire stuff, but I effectively allocated the memory. So it should be I should actually add the size of this buffer to here, right? So it's going to be byte length. There we go. So that effectively copies the memory of the image into that thing, right? into that thing. So what we want to do, we want to do stb load from memory, right? So this is a stb load from memory. That's pretty cool and everything. So let me see. So we provide the buffer, right? So we provide the buffer. The buffer is a queued buff, right? So this is a queued buff, and we also have to provide the length, which is let's call it something like queued length, and it's going to be literally buffer length, and here we just add queued len, so we can then use queued len in here. So, and this one is really interesting. So, because these are the output parameters, we'll have to allocate them also somewhere in on the heap, right? So that means we have to have queued x bump, right? And since they are int, they are 4 bytes, right? So this is going to be this thing. Maybe I can even do it like that. So then queued y, also 4, and then channels in file, right? I suppose I'm not really sure how many channels we have in there. I suppose maybe I can just provide 0 in there, right? I feel like I should be able to just provide a 0 in here, and then we have desired channels, and desired channels is not a pointer. All right, so essentially I can do queued x, queued y. Here I'm going to provide a 0, and desired channels I'm going to say 4, right? Because I hope it's going to basically automatically infer what I mean in here, right? So it will automatically infer what I mean. Okay, so that's pretty cool. And I kind of want to do something like this. And I want to replace this with queued len, right? So this is a queued buffer, this is queued len. So we just take this chunk from a memory, then this is the blob. I should have actually called it queued buffer, all right? I think it would make a little bit more sense. So let's call it queued buffer, there we go. All right, so this entire thing should return me something, right? I suppose it will return, yeah, it should return me like a new thing, like so pixels, ptr, maybe pixels buff, right? So this is the pixels buff. We can try to print all of that, right? We can try to print all of that. Console log pixels buff. All right, so pixels buff. All right, so I'm gonna try to refresh this entire thing, and it was trying to do realloc. That's very cool. And it returned 0 because it didn't really work out, but right, so realloc is not implemented. So this is something that we have to implement now. All right, let's go ahead and do that. So realloc, it should accept the old pointer, right? Old pointer. Let me take a look at this entire stuff. Old pointer and the size. So the thing about realloc is that it's basically copying the old memory into new one, right? It's copying the old memory into new one. So, but usually it also doesn't try to reallocate if it's if the new memory is smaller than the old one, but we have no way to know if it is because we don't store that information anywhere, so we have no choice but actually reallocate every time, which could be fine for now. I think it could be fine anyway. So let's actually allocate. So this is going to be new p, which is basically bump. Right, and then bump plus s, and we're going to return new p in here. But before we can do that, we have to... Man, that sucks. We literally have to store that information somewhere. Right, because libc assumes that you know that. Okay. Allocations, I mean, that's what we can do, I suppose. And then essentially allocations result equal s. Is that something we can do? Maybe. So what do we have in here? Allocations type any. maybe it's going to work anyway. So essentially here, what we have to do is, right, so this is the new s. It's a new else, but we need to have an old s here as well. So we can have allocations, old p, and now we have old size. Right, so if old size is greater than the new size, right, if it's greater than the new size, I suppose we can just take this stuff and just set it to new size, and this is the new size, and just return the old pointer. Let me actually disable fly check mode because it's not particularly useful anymore. Right, so yeah, so something like this, because we keep track of the allocations and stuff like that. So we take the old pointer, if the old size is greater, so we just set the new stuff and blah 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 blah. All right, so the next thing is going to be, so this is const, sure, const, then new pointer, right, new pointer is going to be bump plus new size, allocations, new p, new size, and we return new p. But before we can do that, we need to copy old data into a new one. Right. So essentially we need to do new uint8 instance exports memory buffer. It starts at new pointer new s, right, so new pointer new s, and we set effectively this thing like so. But we set it at an old pointer, but with new s, because we know that new s is greater or equal. In fact, it has to be greater, so let's actually explicitly say that it's going to be greater. There we go, so that's how we're going to be doing all of that. All right, so we've got that. Everything seems to be okie dokie karaoke. I hope I didn't make any fucking... Why am I talking about that? Anyway, so fly check. Let's take a look at fly checks. I don't see anything particularly weird, so I could probably say that those are just numbers. Allocations. I don't really remember how we can specify this kind of stuff, so I can basically say that this is a key, accepts as a string but returns the number, so that's what we can say. Hopefully that helps. Yeah, it does in fact help in here. What's it complaining in here? Export value, it's not a parameter, which is fine. So this one could be just a number. All of these things are numbers as well. There we go. Cool. Yeah. So let's try to refresh. Memcopy. Finally, we've got some more interesting stuff to implement. Memcopy. Finally, memcopy. Let's go and implement memcopy. Memcopy. So destination is going to be a number, source is going to be a number, and the size is going to be also a number, right? So new int it array instance exports memory. Why this thing doesn't complain? I'm surprised. All right, exports memory buffer. So we start at the destination of the size n, and we're basically setting the same thing from the source, and that's it. So as far as I know, we also have to return the... Why did you jump there? Okay. We also have to return destination, right? So just return destination. So that's basically how we copy this information. Right. What else do we need? It returned. It worked. It actually converted the pixels. The fuck? Yo, it freaking worked. What the fuck? This is the pointer, right? So this is basically in the memory where it is located, where the pixels are located. And it didn't throw any fucking error. Holy shit. Wait a second. Okay, so here I just do some bullshit that is not needed actually. Right. So we want to actually read the size of this entire stuff. So the size is located at pointers qt x and qt y. But that's the problem. They are pointers. They are pointers. So we have to actually read them. So we have to take the memory, right? So this is instance experts memory, right? And the memory is located at qt x. But it's actually 32-bit integers. So what we have to do in here is uint32 array, right? So it's, I think it's uint32 array at x with the size 1. And I think in here, it makes it super easy to just read it as 0, right? So that means this should be just x, and I wonder if it's going to work. Right, so let's give it a try. So this one is y, of course. Right. X, X, Y, Y. And it didn't work. It doesn't really work like that. Uint, oh, you have to actually, you know, capitalize that properly. Going to work? Seems to be, it doesn't really complain. Undefined. Okay, so you can't really do shit like that, which is very, very interesting. How can you get? Is there any stuff that you can get? Okay, JavaScript read what memory buffer? Oh yeah, I have to provide the buffer. Thank you. Okay. Should be offset should be multiple of 4. Fuck you. Are you fucking serious? Wait. So it has to be aligned in 32 bits, but since our allocator doesn't really align them, we can't really construct this kind of shit easily. So I suppose I think I can trick this entire thing, right? Right, what if I say, okay, what if we do something like this? Can I then convert this entire thing to 32 array like so? I wonder if I can trick this entire thing like so. Is this a trickable? Yeah, I can. I tricked it. I fucking tricked it. Right, so I created like a separate view on this thing. Right, look at that. X is 64 and Y is 48. Right. So we got like location within the memory and these dimensions. And if we take a look, right, at the dimensions of the image that we have in here, right, so let's actually take a look at them. Yes. These are 64 by 48. I literally took a C library that is probably was not designed for web or anything like that. I compiled it to WebAssembly, I run it, and it parsed PNG. How about that? Let's actually try to read this entire thing, maybe. All right, so it's rather straightforward, should be, I think. I think it should be rather straightforward. So we're gonna take the memory and we're gonna say, okay, pixels buff. Right, so this is a pixels buff. And we have essentially x by y by 4 of those pixels, right? So this is basically the thing that we can feed into something like image data, right? So if I do something like image data, so how can I construct image data? Is there any way I can construct it? It has to be U8 clamped array, all right. JavaScript construct image data from uint8 or something. Thank you so much, ktorn _ for tier 1 subscription. That tricked earn my sub. Thank you. I was like, I mean, I had a choice: either modify the allocator to align everything, or just do something quicker. And I just like my brain went for an easiest thing to do. Well, I mean, if my brain always went for an easiest thing to do, I wouldn't start this project in the first place. But I kind of hate how web, like, you know, suggests you to get the pixels of the images. It's just like it literally triggers me, right? So, and I just like trying to find a better solution. Okay. Create image data, so you can yeah, you create an image data out of that. So I suppose one of the things I can do, I can again steal all of that from olivec, right? I can steal all of that from olivec because why not? I already done it before. So image data, oh yeah, you just like, okay, so you have to make it a clamped array, and you have to provide this thing, and you also have to provide the size. I'm gonna actually literally steal all of that stuff. So index ts. All right. So this is the thing. And width is x, and that gives the image. And then I wonder if console will actually display that image. I wonder if console will actually display. I don't know why I keep recompiling it. Image data. Okay, it doesn't show it. God damn it! I think I already complained about that, right? So they missed such a cool opportunity to actually show, like, display an actual image in here, right? Because you know that it's an image data, right? So it's a well-known type. You could have just like displayed it, I guess. Anyway, all right. So let's actually see if we can literally display it in a canvas, right? So I'm gonna move all of that to Autocell entry point, right? So Autocell entry point, and here I have the context, right? And when I render a single thing, right? When I render a single thing, maybe I can actually do it in here. So ctx draw put image data, right? So put image data. I provide the image at 0, 0, right? And let's see if it's going to work. And unrestricted mode reserved word. Okay, that's really strange. So let me go to index.js. Apparently we did the fucky wacky. Oopsie doopsie. Uvu. Yield. Okay, so I suppose we are in not in async mode. Okay, so I forgot to make this entire thing async. Would you look at that? Seems to be working. All right, but where is the stuff? I don't see the stuff. Excuse me. So I think this is because of some stuff. Am I dumb? Oh yeah, I am. Right, so because I forgot to replace the entry point, right? So I have to use a different entry point now. Yeah. So that should work. Didn't work. I don't see the image in... Wait. Well, I mean, I can put this kind of stuff in here, but the image is not drawn. The image is... Oh yeah, I see why. Because I actually draw the image before the render, so I have to actually draw it on top. There we go. It fucking worked. Holy shit! Yes! So you can... This is so cool. You can wrap it into some sort of a module and distribute it at npm. Right. So yeah, like, that's so cool. So and essentially, you can even have support for image formats that browsers don't support. For instance, there's a huge potential in here, right? Because STB image supports PSD. So technically, this thing is capable of reading PSD files right in the browser. Like right in the browser. So with like you won't be able to do that with the usual web trick, like at all. This is so cool. Chem within Lar, thank you so much for gifting the subs. Thank you everyone for gifting the subs. Really appreciate that. This is so cool. Right, so everyone, thank you so much for subscription. Right, so thank you. Time to create an in-browser Photoshop. Yeah, I mean, that's one way to do that. As far as I know, Figma like actually very extensively uses WASM, right? So it's primarily written like in C++ or something like that. But I don't know for sure. Right, and now, like it's kind of difficult to tell, right? So I was trying to make this thing to reduce the amount of bullshit, but isn't right. Compiling the WASM module, loading the WASM module, then getting the pixels of the image, putting it in the memory, and then running this entire thing even more bullshit? I don't know, but at least it makes sense, right? So the thing that triggered me with the web solution is that it doesn't fucking make sense. I fucking hate it, right? You have to load the image through an image node. You have to have an off-screen canvas. You have to put an image onto the off-screen canvas, and only then you'll be able to get the data. It's just stupid. It fucking triggers me. Like, I don't know why, but it fucking triggers me. It's just like I'm trying to shake. Like, how is that the solution? How is that the solution? What you want to do, you want to get the freaking pixels. You already have the pixels when you already loaded the image. Just give me the goddamn pixels. Just give me the goddamn pixels. No, I'm not gonna give you. You have to go through these hoops because the W3 consortium didn't come up with a better solution. It's just like I can know. The inner sense of beauty is really like, it's like really offended by this solution, right? So I don't know. This is like I refuse. I refuse to believe that that's the solution to this problem, right? I refuse. But here what we do, we literally retrieve the pixels of the image from the internet. We get the program capable of parsing the format of the bytes that we received. We give this byte to this program. We received parsed data, and there you go, we can use the parsed data. It's a little bit more code, but it makes sense. It is reasonable. You get the bytes of the format, you have the program parsing the format, you give one thing to another, it spits out the thing, and you just use it. It's that simple. It's so fucking cool. Anyway, so we can try to maybe now analyze the pixels, right? So in here we got the pixels. So that's the image. We basically draw that image, but we don't really have to draw that, right? We don't really have to draw that. What we have to do is maybe turn it into array of u32s, right? So I'm gonna actually make it array of uint, right, like so. So this is just an array, but then I'm gonna do the trick yet again to turn it into array of pixels, right? So this is basically the pixels. This is basically the pixels. I'm not going to print any of this stuff. And one of the things I want you to do, like why I want you to have a pixels, is actually compute how many unique pixels I have, right? How many unique pixels I have. So I could create something like unique pixels, and this is going to be a thing that I suppose accepts maybe a key. Can I have a key which is a number? Maybe I can, and also as a number. So I'm gonna iterate through all of the pixels in here, right? So I less than pixels length. Yeah, so this is gonna be the length. There we go. And if unique pixels I is equal to undefined, we're going to so it complains about something, probably because I didn't initialize this stuff. Yeah, we're gonna set this thing to just 1. Otherwise, if it is defined, if it does exist, we're gonna simply you know, increment it by 1. There we go. So that's what I want you to do. And then I want to just go ahead and print the unique pixels. I just want to print the unique pixels. Let's see if it's going to work. So these are the unique pixels that we have within that specific image, right? And the project that we're working on, right? The project that we're working on is essentially an attempt to generate a cellular automaton based on an image. Right. So, and essentially the unique pixels that we have in here could be the states of the cellular automaton, right? And now we're capable of actually doing all of that. So this one is a bit weird, right? I suppose maybe what I have to do is, yeah, this is absolutely weird. So this is not how we're supposed to do that. I want to reinterpret this entire thing. Do I have to say it as a buffer? Maybe. Yeah, I had to set it as a buffer. I think that's the problem in here. Right, so there's a lot of things in here, right? It's lagging. It's yeah, it is lagging. It cannot open it. God damn it! Can you kill it? Please kill it. Thank you so much. Yeah. Maybe we can iterate the object. Right? Maybe you. We can iterate the object. JavaScript. Iterate object key value. I don't remember how to do that. So for each, this is, I don't like that. I think I remember. Yeah, I remember some scheisse regarding that. We can iterate keys and then get the keys and stuff like that. I think that's gonna be fine. Right, so for let key, I even like the solution in unique pixels. All right, and in here we're gonna just do console log. Maybe I can even do key unique pixels key. So it's just it's a histogram, right? So that what we're doing in here is just simply histogram. Okay, so good, some stuff. It is lagging a bit, but I suppose, yeah, that was a bad idea. So it doesn't even display the console. That's how much, yeah. My laptop is extremely slow, especially when I'm streaming, so it's kind of difficult for me to do this kind of stuff in here. Right. Yikes. But anyway, right. So we are now capable of computing the unique pixels. We just like cannot see them. One of the things we can probably do is get the amount of unique pixels. Right. JavaScript size of object. Right. Why it's lagging? Because I have 10 years old laptop. What's the deal with old laptops, Zozin? Just buy a new one. Aha! Ah! Just buy a new one. Zozin, are you dumb? Why are you using old laptop? Just buy a new one. Aha! 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 So keys, can I just do something like that? Unique pixels, right? Length. All right, so I just want to see this thing. Skill issue, yeah. I just have a skill issue. Yo, we have almost 2,000 unique pixels. That is bullshit, I believe. That is kind of bullshit. I have a feeling that it could be something with interpolation, because if you take a look at the you know, at the image itself, it's kind of hard to believe that you have 2,000 unique colors in here. Do they have 2,000 unique colors in here? I actually doubt that. So I think I did a fucky-wacky somewhere with computing and stuff like that, but it doesn't really matter. It's already details. But yeah, in any case, I'm capable of actually getting the pixels nonetheless. Right. 3 plus alpha. Yeah, it could be because of alpha, by the way. Right, maybe alpha is just like has a lot of variance and stuff like that. Or maybe I just took a slice and view incorrectly, like in here. That could have been the case as well, right? That could have been the case as well. So we can do something like console log pixels length, just to see the length of this entire thing. Yeah, so it's 32,000, which is obviously bullshit, right? How did you get 32,000 in here? Right, it doesn't make any sense because we have 64 by 48, and it's like it's magnitude smaller. So there's some fucky-wacky and oopsie-doopsie going on in here, but I'm a little bit too lazy to figure that out, and it doesn't really matter that much, right? It doesn't really matter that much. So what's important is that we managed to actually run STB in the browser. The fuck? And it was surprisingly easy. It was actually surprisingly easy. I didn't expect that it will work out. So I didn't expect that it will actually work out, but it did in fact work out. So maybe we can use that. So, and WASM module itself is not that big, right? I mean, it's certainly smaller than some of the websites, but yeah. I'm pretty sure you can probably make it even smaller by cutting out some of the implementations, right? Because, as I already said, you can parse PSD, but do we need PSD in here? So how much smaller would it become if we just like cut it out? And I'm pretty sure maybe there is some macros to cut it out, right? So PSD, there's something like no PSD. Yeah, yeah. You can just like define all of this shit, right? And I wonder how small it will become. No PSD. Let's give it a try. So STB image C, right? We are gonna leave only PNG, right? Pretty cool. You can actually customize this library like very heavily. Fine, but we're only gonna, well, I mean, yeah, cool. So let's do build, and let me see. Probably smaller than Twitch, yeah. 34 kilobytes. 34 kilobytes. How about that? There's also only PNG. Okay. So let me see. STBH only. Yeah, that's pretty cool. That's even better, I think. It's like only fans, but only PNG. Yes. And it only was talking about like free and memset. Yeah, it's pretty cool. That's rather fast as well, considering that I'm also streaming everything. So, so the fact that this thing is displaying in here is sort of like the proof that we managed to parse the image that we received from the internet. Right. So what's funny is that it feels like this could be the way the web evolves in the future. You know what I mean? Essentially, right. So the JavaScript will become sort of like a glue, and all of the like heavy lifting is going to be done by like WebAssembly, like modules that you write in C and C++ and stuff like that. But it's kind of more complicated than that because WASM cannot do shit without WebAssembly. It cannot access any of the you know, I/O features, for instance, right? It cannot do WebGL, it cannot do WebGPU, right? All of the APIs that get added to the browser, they are by default inaccessible to WebAssembly. You can only access them if you create bindings through JavaScript and stuff like that. It's kind of a weird architecture. Right, but it is what it is. So WebAssembly by itself is incapable of accessing none of these newest APIs, right? Only JavaScript can do that, right? So WASM is more like reserved for crunching numbers, right? So essentially, it's really good for literally transforming bytes, right? If you have a job that requires taking a sequence of bytes and transforming it into another sequence of bytes, you can do that in WebAssembly. So that job may include parsing PNG files, encoding videos, encrypting things, and stuff like that, right? But if it involves interacting with like hardware, like web GPU, is just like you have to do that through JavaScript anyway. All right. So we've got some subs, by the way. I don't know if I acknowledge Finan Darcy. Thank you so much for tier 1. And Mr. Foes, thank you so much for Twitch Prime. Thank you, thank you, thank you. All right, so I've achieved everything I wanted to achieve for today. So we got the pixels. And I guess it's time for me to go. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all next time. Love you. Mwah.